Hello and welcome back to our lectures. Today we'll be talking about alkynes. We'll look at their nomenclature and properties. That is exactly what we're. So remember that this is a continuation of the lesson on unsaturated hydrocarbons. Let us take it off from there immediately without wasting time. As usual, I have a beautiful quote from a legend of peace and love, Mahatma Gandhi. He says, "The future depends on what you do today." This is a food for thought. Let's get at it immediately. Now, what are our learning objectives? At the end of this class today, we'll be achieving about three things. One, we're going to be using the IUPAC to name alkynes and draw their structural formulas. Number two, we will understand the physical and the chemical properties. We understand the physical properties of alkynes. And number three, we will understand and write the reactions for the chemical properties of alkynes. The chemical properties, of course, is similar to those of alkenes as well, because both of them are unsaturated hydrocarbons. But we're going to move on immediately and take it up from there. Alkynes. What are alkynes? Alkynes are the last class, second to the last class of hydrocarbons that are characterized. Remember, I usually show you that my block of hydrocarbons each time, but I didn't show it here this time. Now, characterized by the presence of the triple bond between carbon to carbon atoms. They have triple bond. That you must see at least one triple bond, no matter how long the chain is. Of course, the commonest among them, for you to form any double or triple bond, it has to form two carbons. So the commonest is the ethane gas that has two carbon atoms, commonly called acetylene, and is the simplest alkyne and is used for fuel, for torches, and in making plastics as well. So this is what we call the acetylene gas, because that's the two. And if you look at this, carbon has triple bond here. So 1, 2, 3 to satisfy it just needed one hydrogen from both sides. So these are hydrocarbons that are characterized by the presence of at least one double bond in their carbon chain. And what is this going to tell us is that we have to make this triple bond the priority in trying to identify and name them. And that is exactly what we've been doing next. Now, the nomenclature of alkynes is just exactly the same as the nomenclature of alkenes. But I'm still going to give you those rules, to guide us to see what is going on. So I'm going to just read out this real quickly and then we go on. It says, so the nomenclature, number one, we're going to name the longest chain that contains the triple bond. Remember, our primary focus here is on this triple bond. Then we're going to be using the root name, YNE in this case. Remember, in alkenes, we use ENE. In this case, we're going to be using the YNE. So it's going to be, like I said, ethyne, propyne, butane for the unbranched ones. Now we're going to number the chains so that carbon atoms joined by this triple bond get the lowest number possible. So our interest in naming the long chain is focused on the triple bond. The direction of the triple bond will have to get the lowest number. We now locate the triple bond and the position. We're going to, of course, always locate the position of the triple bond. It is very, very important because that is the only way we can understand where attachment of the triple bonds are placed. Then we're going to locate and name other attachments it has, no matter what attachment is, whether methyl or generally, whether an alkyl group or any of the halogens, or nitro, any attachment. And then we're going to combine the names together and then give it a name through the longest chain. Of course, the longest chain must end at "-ine". And if necessary, where you have more than 2 or 3 attachments, you have to alphabetize if necessary or where necessary. So let's take a cue from these two I have here. I have 2 simple ones here. Now, the first thing we need to do is to count the longest chain. Let's count it. So if I count from here, it's going to be, if you count from here, now remember, okay, I usually like doing, as a start, I'll count from both sides. So if I count from here, 1, 2, 3, 4. That's, of course, this is a long chain. It doesn't have any branch. But you see here now, we've given the triple bond number 3. But this is wrong. We can count from here 1, 2, 3, 4, giving it number 1. And again, like I said, the IUPAC root name for this will be "-ine". And the longest chain is butene. Remember, this will be but. Then we're going to remove the ANE or ENE and now put YN. So it's going to be butane. Where is the double bond located? It's located in carbon number 1. This is going to be 1-butane. That is how we name this, 1-butane. Okay, let's look at the second one. Again, we have to count in a direction that gives the triple bond the lowest number. Let's see this. This gets if I come from here, this gets number 1, of course, this should be the best number. This gets number 2, 3, and 4. You can also count 1, 2, 3, 4. Okay, whichever we count is the longest chain is 4. So what that simply tells us is that we have an attachment at this point, which is in carbon number 3. Again, remember, if a number from here is going to be wrong. So having done that, okay, I'm going to take away the other wrong number in here, not to confuse you. Remember, this number is the wrong one. I want to leave only the right one. Okay. Now, what does that tell us? It tells us that this is an attachment. Of course, this attachment is the methyl group. So if we want to name this thing, now let me start from the ending. The longest chain, of course, is but. And then it is an alkyne, so I'm going to say butane. The double bond is located in carbon number 1 here. And then where's the attachment located? Remember, in IUPAC nomenclature, the prefix or the attachment comes first. The prefix, number, and identity of the attachment. The longest chain now, which is this one. And then the functional class is YNE. So we're remaining with this one, the attachment. So what is it going to be? It is going to be a carbon number 3. So we're going to have 3 methyl 1 butane. That becomes the IUPAC nomenclature of these compounds. So to make this easy, we're going to be taking some reflection questions that will help us focus on this numbering. Again, let's start from this one. This is a long chain. It doesn't have any attachment. It's easy to name. Let's see. If you come from here, 1, 2, 3, 4. If I come from here, 1, 2. Oh, anywhere you come from here, it gives you 2. Let's see. 1, 2, 3, 4. You see, counting from any of the sides gives you 2. So this is easy. Again, the longest chain is butane. It doesn't have any attachment. So there's no prefix or attachment here. So what are we going to do? We name it through here. The triple bond is located at carbon number 2. So this is going to be 2. Of course, let me use my red. The longest chain is butene. So this is going to be just 2 butane. It is an unbranched alkyne. Now let's get to this one. Let's look at this one. If you look at this one again, remember, the longest chain has to contain the triple bond. So if you count this thing now, 1, 2, 3, 4, 5. This is the long chain. 3, 4, 5. But there's no triple bond. So that means this is wrong. What are we going to do? We have to count it in a direction. Remember what I told you earlier, particularly, I think that should be in the review. I told you that anytime you see a triple bond, the next carbon to it must be in a linear chain because it makes it linear. That is why it has that geometry of 180 degrees. So let's name this. So we're going to count this. My students make a lot of this mistake. Remember, there's a carbon here because there has to be carbon between 2 triple bonds. So this is going to be 1, 2. If I put this 3, 4, 5. If I also count from here, 1, 2, 3, 4, 5. Or whichever way, it's going to give me 5. So I'm counting like my direction. If you count this, so what it means is that there is 2 carbon attached there, 1, 2. This is an ethyl group. So I'm going to cover it now. This is an ethyl group, which is the attachment. So if we're going to name this thing now, what is it going to be? We have the triple bond in carbon number 1. That's what I mean, between 1 and 2. So it's in carbon number 1. So we're going to say, and the attachment is carbon number 3. So it's going to be, I hope I have my red. It's going to be 3. Oh no, that's not metal. Remember, this is ethyl. I almost made that mistake. I wrote it down there. 3 ethyl. The triple bond is located in carbon number 1. 1. The longest chain is 1, 2, 3, 4, 5. Remember, 1, 2, 3, 4, 5. This is pentane. It's going to be pentane. That is how we name this. Now we get to this one again. We count again. We try to count. Remember, the longest chain will have to what? Contain the what? Contain the triple bond. So if you count from here, there's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If I come from here, 1, 2, okay, if you come from here, it's 1, 2. If you come from here, it gives you 1, 2, 3. We can't go from this side. So the correct number must be from 1, 2, 3, 4, 5. Okay, let me do the wrong numbering for you and show you. So if I count them from here, it's going to be 1, 2, 1, 2, okay, 3, 4, 5. Look at what is happening here. The triple bond is getting 3 from the green counting I did. Whereas from here it's getting 2. So the green counting is definitely the wrong one. So what am I going to do? I'm going to take it off immediately because that is not the correct one. So having gotten the correct counting, let's look for attachment. There are 2 attachments here. There's one attachment at this point, which is a metal group. And there's this, remember, this is metal. And this is bromo. So now we're going to, first of all, put those attachments in front. Now, of course, B comes before M, so automatically we're going to put it first. So let's write it. It's going to be, bromine is located in carbon number 1, so it's going to be 1 bromo. Then this is methyl group is located in carbon number 4. It's going to be 4 methyl, 2 pentyne, because the longest chain is pent 5. 1, 2, 3, 4, 5. So this is going to be, remember the triple bond is located from here in carbon number 2. So it's going to be 2 pentyne. If I'm going to squeeze that, I'm going to go to the next layer so that I don't mess it up. So it's going to be 2 pentyne. And this becomes the name of this compound. 1 bromo, 4 methyl, 2 pentyne. Now we'll go to the last one here, the last but not the least of those numbers. Let's look at it. We have our triple bond from here. So definitely this direction will give us the best counting. So let's see which long chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So whichever way you count, it's going to be 7. So I'm going to take this one. I'm going to take this one. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7 is the longest chain. Now let's identify our attachment. What are there are 3 attachments from this now. Okay, let me use a different color. Now this is a methyl group in carbon number 5. Another methyl group here in carbon number what? In carbon number 6. That's what we have. And then not that, we also have this. What is the Christmas tree? This is the Christmas tree. Tet butyl. We have a tet butyl in carbon number 4. Okay, let me use a different color for that. So there's this tet butyl here. That one, yeah, there's tet butyl in carbon number 4. So we'll put everything together. Butyl comes before methyl, so we're good. Remember, I told you the tet is the prefix, so you're counting the B. So it's going to be, it's located in carbon number 4. So we're going to say 4, it's carbon number 4, tet butyl, 4 tet butyl. At times you can say T butyl, that's okay. 4 tet butyl. The next attachment we have is what? In carbon number 5 and carbon number 6. So it's going to be 5, 6 dimethyl. 5, 6 dimethyl. Then the next you're going to put a hyphen. 5, 6 dimethyl. Now we've taken care of the attachment. Where is the triple bond located in carbon number 1? It's going to be 1. Then the longest chain is 7, hept. Hept. Of course, you have to put the end Y and E. Y and E. So this becomes the name of this compound. This is how we name this compound. 4 tet butyl, 5, 6 dimethyl, because there are 2 of them, located in 5 and 6 dimethyl, and the triple bond is carbon number 1 heptane. This is how we name this. Let's proceed to the next one. Now, in the next, this reflection now, I have just the names, and now we're going to figure out how to draw them from their name, because these are the 2 ways we usually test you in exam. Either you name it when we draw it, or you draw it when we give you the name. In this case, it's 5-methyl, 4-nitro, 2-hexane. I tell students, in drawing this thing, remember, the moment you put a carbon before the triple bond, we have to be in a straight line. And then, after that, it has to be a straight line. Because anytime you see a triple bond, it has that 180 degrees bond angle, or that linear geometry. Okay, remember. So the longest chain we're going to get here is 7. And then it says we have the triple bond in carbon number 2. That's what we said. So I'm going to try to start from the end. That's what I'm going to do. So I'm going to say, let's see, 6. Let me do this one. I'm going to say 1. I can't use it like writing with this. Okay. I'm going to say 1, 2, 3. No, I don't like how this looked. Now, okay, 1, 2, 3, 4. And then, if I put my triple bond here, and that means another carbon that will be will now be another long one again. So let's see if I count. 1, 2, 3, 1, 2, 3, 4, 5, 6. I got that. That's correct. Okay, let's count it before we continue. So if I'm going to count with my blue, so I'm going to say 1, 2, 3, 4, 5, and 6. Hexyne. That's I've gotten this. And this is carbon number 2 between 2 and 3. This is correct. So I'm going to put my nitro. My nitro is located in number 4, 4 nitro. So I'm going to say this is number 4. Nitro is NO2. Any other thing? And the methyl group is in carbon number 5 here. So I'm going to say, you can say CH3. Or you just put it, you don't have to put CH3. I just decided to put it. You don't have to. You can just draw the line straight. So let's try to make sure this is correct. 5 methyl is in carbon number 5. 4 nitro, carbon number 4. 4 nitro, 2, carbon number 2. Triple bond is carbon number 2 and 3. 2, hexyne, 1, 2, 3, 4, 5, 6. This is how we draw this. Correct. Now let's look for the next one. The next one says 3 ethyl, 1 pentyne. Just 5 carbon. But now, it's located in carbon number 1. Okay, let me put that first. Let me first of all put that. Let's see. So if I start from carbon number 1 to be the triple bond, what it means, the next carbon following it must have to be straight. So it's going to be 1, 2, 3. This is the triple carbon. 1, 2, 3. Then I can now bend 4 and 5. Let's see. 1, 2, 3, 4, 5. Yeah, that's correct. So if you number, let me number first before I put other ones. So this is going to be 1, 2, 3, 4, and 5. That's correct. Remember, it says this is 1 pentyne now. We've just gotten this side first. I've got this is 1 pentyne. 3 ethyl in carbon number 3. 1, 2, 3. Remember, I'm going to put my ethyl group at this point. Let's see. So it's going to be 2. That's ethyl group. Carbon 1, 2. So this is how you draw 3 ethyl, 1 pentyne. Good job. All right, let's go to the next one. It says 6 chloro. Okay, let's do this one first, then we'll do this one last. This one now is the long chain, 4 octyne. This one just simply telling you that there is a double bond in carbon number 4, and it is 8. So let's just draw it. Let's see. I'm going to start from here. I'm going to say 1, 2, 3, 4. I have my triple bond in 4. So that means it is between 4 and 5. It's going to be a long chain. So it's going to be 1, 2, 3, 4. Yeah, carbon number 4. This is 5. The next one following it has to be straight. 6, 7, and 8. Let's see. Let's count. Let me try to use my blue. So if I count 1, 2, 3, 4. Yeah, 4 octane. 4, 5, 6, 7, 8. That is correct. This is 4 octane. It is located in carbon number 4, the triple bond, and it's a straight chain alkyne. Let's now talk about the last one here, but not the least. It says 6 chloro, 2 fluoro, 3 heptane. Longest chain is 7. Let's see. And the triple bond is located in carbon number 3, right? In carbon number 3. So if I start from 1, 2, 3. So that means it's going to be between 3 and 4. So this is going to be 3, 4. It's going to be here. So this is 1, 2, 3. 1, 2, 3, 4. Then the next one is going to be 5. Then 6 and 7. Let's count. Let's love it. This is going to be 1, 2, 3, 4, 5, 6, 7. Correct. That is our longest chain. And this is between 3 and 4. Remember, 3 heptane, 1, 2, 3. Now we start adding. In carbon number 6, we have chlorine. That's what it means there. So in carbon number 6 is here. You put chlorine. What else? 6 chloro, 2 fluorine. Carbon number 2, there is fluorine. And it makes sense because C comes before F. In carbon number 2, so I'm going to put it here. This is, in carbon number 2 here, there is F. So this is how we draw this. This is 6 fluoro, 2 fluoro, 1, 2, 3, 3 heptane. This is the correct structure of this molecule. So we have to practice. So I always advise you that when doing this problem, like I have a lot of them, if I do phase 2, you can pause the video, take a cue of what I did, do the problems yourself before coming back to see how I arrived at my answer of drawing or structure. All right, let's take it off from there immediately and go to the next thing we need to talk about, the properties of alkynes. Now we're talking about both the physical and chemical properties. So the physical properties of The physical properties of alkynes are like those of both the alkanes and the alkenes, because they are all hydrocarbons. Remember that, don't forget. And hydrocarbons contain only carbon and hydrogen. So what that tells you, the implication is that anytime something contains carbon and hydrogen bond is a nonpolar bond. So it's going to be very nonpolar or hydrophobic. So they will be insoluble in water. They are less dense than water. They have lower density than water. They have low melting and boiling point because they only have London dispersion forces as the only intermolecular force playing out there, as the only IMF playing out. Now, the physical properties, of course, changes as they go down, as the molecular weight increases, or as you go down the group. As you go down the group from ethyne to propyne to butane to pentane and down, the properties increase, telling you they are homologous series. So they're going to change, of course, from gases to liquid and from liquid to solid. Now, what about their chemical properties? They undergo both combustion and addition reactions, just like the alkenes. Combustion, remember, every hydrocarbon I told you on combustion will generate carbon dioxide and water. That one is basic. All their combustion reaction is the same thing. Their combustion will always generate carbon dioxide plus water. However, it also undergoes addition reactions. Addition of both hydrogen, which is hydrogenation, addition of halogen, hydrohalogenation, addition of water, hydration, and addition of hydrohalogen or alkyl halide to form alkyl halide. So that is hydrohalogenation. So it undergoes all those addition reactions of alkene. However, something is different. I'm going to show you. So let me read my note a little bit. It says similar to alkenes in addition reaction. They react with both bromine, hydrogen, HCl, and HBr, HF, and HI. Now, the only difference between alkene reaction and alkyne reaction is that they require twice as many moles of addition reagent of alkene. Now, if an alkene would take just 1 mole of hydrogen to get saturated, an alkyne will take 2 moles of hydrogen or 4 atoms. So that is the difference between it. And it also obeys the Markovnikov's rule. Now, usually we don't ask you a lot of questions based on this, but because it's similarly the same thing, it's just exactly the same concept. The only difference this time is that the reaction is going to complete and it's taking more of those reaction reagents. Let's see them. So I'm going to just demonstrate a few of them here. Here I'm going to demonstrate in the first reaction is hydrogenation, addition of hydrogen. The second reaction is halogenation. Adding a halogen, example here is chlorine. So this is going to be chlorination. So in the first reaction, this is the, remember I told you this is the hydrogenation. In hydrogenation, look at what is happening. When I did alkene, I never put 2 here. So it's taking 2 moles of hydrogen, or you can say 4 atoms of hydrogen, because 4 atoms of hydrogen make up 2 moles of hydrogen. So what's going to happen? To saturate this completely, for the reaction to go into completion, I'm going to put the usual 3 carbons. Now look at what is happening here. Initially, it has just this. Remember, look at what you have there initially. There's no hydrogen here, and then here has another 3. So what are you doing? You are saturating this. You're adding new bond. Let me use a different color. So we're adding 4 hydrogen atoms here, 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 and here to saturate this. This is exactly how you do this problem. So it takes 2 moles. If it's an alkene will have triple bonds. So it has to only take 2 atoms of hydrogen or 1 mole of hydrogen. So the main difference, like I said again, this is usually a good multiple choice question, is that alkynes take twice as much of the reaction reagent than alkenes. The same thing is going to happen here. For you to use this chlorine to saturate it, you have to take 4 atoms or 2 moles of chlorine gas. Of course, these are all gases. Now, let's see what's going to happen. Again, the same thing here. I'm going to draw the ones that will not change. Now, this chlorine is going to be added. I'm going to use a different color. The chlorine will be added here, here, because there are 4 of them here, here, and here. This is exactly how. So you find out that, now look again. This is 1, if you want to count it, 1, 2, anywhere I can to give you 1. So this is propyne. Propyne was converted to what? Propane. No, propyne, yeah. Let's see. was converted to propane, completely saturated. Now look at this one too. This one is another propane. Here you have added what? 4. So here there's a lot of them. If you want to name this, you're going to say, okay, if you come from here, 1, 2, 3. Come from here. So it's going to be, okay, if I come from here, let's see, 1, 2, 3. Now remember, this is propane. That's the longest chain now because it's been saturated. So this is going to be propane. Now where do we have located? So it's going to be 1, 1, 1. And I get the same thing here. 2, 2, tetrachloro. Okay, I'm going to clean this. I don't have enough space. 1, 1, 2, 2, tetrachloro. Propane. That's exactly how you name this. But I don't expect you to be naming this at this point. Remember, it's just, I just want to teach you a little bit and then solve some more problems. But we don't have to, particularly when I'm testing you in reaction, I'm not testing you in nomenclature. I just like separating that so that I don't have to overwhelm you because I know that this class is not a major chemistry class. All right, let's go